All right, ladies and gentlemen, today we're going to go over our earthquake notes. So, what is an earthquake? An earthquake is the movement of the Earth's crust that results in the release of a built up potential energy from the two tectonic plates being stuck next to each other. The example I saw online for this that I liked, I figured I'd include it here. It's like when your teacher loses their marbles after being asked the same question 15 times in a row. So that pressure builds up and builds up and builds up, and then suddenly there's a very explosive release of energy that causes the earthquake, or that is the earthquake. All right. Sorry, thought I skipped a slide there. Seismic waves. So these are what we actually feel during an earthquake. The first type of waves are P waves. P waves stand for primary waves. These are the fastest moving seismic waves that we have. And as a result, they're the first to arrive, making them the primary wave. These are longitudinal waves, which means they move or they oscillate in the same direction of their movement, kind of like a slinky where there's areas of compression and then areas where it's spread out. Um, Now, like I was saying, these are longitudinal waves that move with a push-pull motion, so they're going to kind of slinky along this way or oscillate that way. Then there are S waves. The S stands for secondary waves. These are the second waves to arrive. They are transverse waves that move side to side as they travel. So they're moving this way, but they're oscillating this way. All right. This is more of a standard wave motion. Now, both of these two waves, P waves and S waves, travel through the Earth as well. Then we have our surface waves. Now, there are two different types of surface waves. You don't need to know the names of those types, but you do need to know what surface waves are. Surface waves are the slowest moving waves. They cause the most damage, and that's because they're moving along the surface where we have all of our stuff. These waves move up and down as well as side to side, and as a result, they can cause a lot of damage because of those differing motions there. Now, locating an epicenter. So to locate the epicenter or where an earthquake occurs, we need to use what's called a seismic station. These seismic stations are able to detect even the smallest amounts of vibration in the earth, and so we have them spaced out all over the planet to help us detect and locate these earthquakes. Now, seismic stations detect and measure the difference between the P and the S waves arrival to determine how far away the earthquake is. So they measure the difference in when the P wave arrives to when the S wave arrives, and that tells them how far away the earthquake must have been based on how fast P waves travel versus how fast S waves travel. Now, once they know that distance, they're able to draw a circle around that station, just like we can see here. And that each station knows that that earthquake must have occurred somewhere along that circle because that's when that or how far away that was. Now, we need three stations to determine where the epicenter is because we need to see the overlap of all three stations. If we only had two stations, look at Portland and Salt Lake City here. If we only had these two stations, it would leave us with two spots where both of them overlap. But with the addition of our third station in Los Angeles here, we're able to see where all three overlap at that one similar point, which gives us the location of our epicenter. What is an epicenter anyway? Now, epicenters are the point on the Earth's surface that's directly above the focus. This is where most of the shaking occurs and where most of the damage occurs as well. Now, focus, just to keep going down this rabbit hole here, the focus is the spot inside of the Earth's crust directly below the epicenter that falls along that fault line where the energy was released from the Earth or that caused the earthquake. So right here is the focus. The epicenter is the spot on the surface above it. You can see that the epicenter isn't necessarily on the fault line because the fault lines aren't necessarily going to go straight up and down based on where they're at on the surface. They can follow an angle, which tells us where the focus is. Now, there are three different main types of fault lines involved with earthquakes. A fault is a region on the Earth's surface broken into two pieces. Now, there are three different types of motion, like I was saying. And the one thing you need to know here is that in the diagrams, the hanging wall is a side that moves up or down. So we can see right here, this part moved up, that's our hanging wall, and this part moved down, that's our hanging wall right here. The foot wall has that downward slope or points down there. All right. Kind of looks like a doorstop, and then this thing is either going to slide up or slide down that doorstop. Now, a normal fault is when we have two plates that are pulling apart. The hanging wall slides down, the footwall block may slide up a little bit. It's likely just staying right where it is as these two plates pull apart. Here, we can see here's our hanging wall that slid down. This is the footwall right here. And the way we're able to tell is by looking at the striations in the rock, or these lines in the rock. We can see that they've been displaced and they're no longer congruent through here. A reverse fault is the exact opposite, where the hanging wall block slides upwards. We can see right here and right here where that has happened as these two plates have pushed together. So these two have come together, or probably along the convergent boundary here, and as a result they've moved in and slid. And again, you can see where the striations no longer line up on these rock walls. Then there are strike-slip faults. Strike-slip faults are vertical or nearly vertical fractures where the blocks have moved horizontally. So these are going to be mostly straight up and down, while these were angled through the block. You see we've got the angle there, versus these being almost perfectly up and down. Now, they can have right lateral or left lateral slip faults, depending on which side is moving towards you from your perspective. Now, here are a couple examples of those lateral faults there. You can see that this road was once a connected road, and then suddenly there was an earthquake, and we had looks like a couple meter shift in the earth. And as a result, this road no longer lines up. Here's an instance in a farmer's field where these crops are no longer lined up like they normally would. They take a little jog right here from where the earth has shifted a couple feet. Now, these are pretty extreme examples. This isn't always the case for every earthquake, but larger earthquakes are going to result in larger movement of those tectonic plates. And sometimes it can make a visible difference. All right, ladies and gentlemen, this concludes our notes for today. I hope you guys have a